Welcome to this session on enabling page size agnostic AOSP builds on development boards. My name is Amit Pundir. Sumit Semwal, who prepared this presentation, unfortunately could not be here this week at Connect. So I'll be covering this presentation for him. I'll do my best to represent his work accurately and answer any questions if you may have. About me, my name is Amit Pundir. I'm a senior engineer in Linaro. I have 10 plus years of experience in AOSP bring up and maintenance. You can catch me on these IRC channels. Right, so in this session, I'll talk about page size agnostic AOSP builds from 16K page size point of view. I'll talk about the changes that have gone into Android Core OS to support that. I'll talk about how to enable page size agnostic builds for your device, the challenges that we have run into, and the workarounds. We did test run of some top rated apps on Android apps, and I'll talk about the runtime status of those apps for their 16K readiness. These apps are downloaded from open app stores like F-Droid, and some have been downloaded directly from developer websites. And finally, I'll talk about the status of testing of 16K AOSP builds in Linaro. So what is page size agnostic AOSP build? It means that the AOSP build do not make any page size assumptions. The same application can run on 4K as well as on 16K AOSP build. It's not just about making OS or applications page size agnostic, but also optimizing them for larger page size when available. 16K page size AOSP builds reports 5 to 10% increase in overall performance at the 9% additional memory cost. And you can check out this AOSP blog for more information on the 16K page size enablement and 16K page size support in Android. Right, so to make the OS truly page size agnostic, AOSP was refactored from the ground up to support running at different page sizes. By getting rid of compile time page size macro, by making sure that the binaries are 16K aligned, and by building binaries with separate loadable segments. And then there are some noticeable changes in how Android manage different file systems in page size agnostic builds. For the performance combination, it turned out that the file system block size must match the kernel page size. But for compatibility point of view, from the page agnostic point of view, some file systems support different page size enablement as well. For example, on F2FS, the block size should match the kernel page size, while ext4 and EROFS, they support page size agnostic builds when built with 4K block size. Due to this current state of file systems, it is advisable to stick to ext4 and EROFS for page size agnostic builds at this time. Now comes the part where we start enabling build options to make it page size agnostic. We have enabled these couple of build flags in Android. The first one takes care of ignoring the page size macro. The second one, the more importantly, specified the max page size supported by your device for example, in this case, for the 16K alignment. Also to be noted is that in Android, the 16K page size builds are only supported for 64-bit devices only. The default page size in Linux kernel is 4K, so we had to make sure that we are building the kernel with the correct page size option if you are using the basal build configuration, or in the device def config if we are doing the standard make builds. We needed to rebuild upstream Mesa for 16K alignment, otherwise we were running into few runtime issues. And some file system config updates for page size agnostic builds that I have discussed in the earlier slide. Now, the challenges that we have run into while trying to run 16K AOSP build on our dev boards. Some were platform SOC specific issues, like we caught this Adreno SMMU issue on RB3, which got fixed in upstream kernel. I already talked about the 16K alignment issues with the upstream Mesa build. And then there were some AOSP breakages like Chromium WebView, where we were running into runtime crashes on 16K builds due to stale or 4K pre-builds in AOSP. Another interesting bug that we ran into was in the ABL bootloader, in the Qualcomm's ABL bootloader, wherein the bootloader could not unpack 16K boot images. So we needed to pack the boot images with 4K page size explicitly by specifying these couple of build flags. Now in this section, I'll talk about the third-party apps. Most of the apps are likely built with 4K page size in mind. So the apps that make use of native libraries need to be aligned with the page size, with the appropriate page size. In some cases, 16K compatibility mode may help those apps run on 16K builds unless the apps have some hard-coded page size assumptions. If possible, we need to rebuild them to realign them with 16K page size so the binaries are compatible with both 4K and 16K page size devices. We test run a few top-rated apps to check their 16K readiness. Some of these are installed from F-Droid public app store, while others are downloaded directly from their developer website. I've listed down the applications that we have test run, and I'll talk about their runtime behavior. We verified that, to start with, we verified that all the apps work on the default 4K page size build, just to make sure that the applications are not broken in any way. Some of these apps work on 16K page size AOSP builds. And a quick look at the native libraries revealed that the native code, the native libraries were already 16K aligned. There's a shell script in AOSP code base which can be used to find out the library's alignment of an app. The rest of the apps do not have their ELF segments 16K aligned, but we were counting on the 16K compatibility option in Android to do the magic and make the applications work, and that worked for VLC. VLC worked in 16K page size compatibility mode. 3D Mark benchmarking application, it started in compatibility mode, but it crashed later on. The other apps just failed to load. Most likely because these apps are likely making the page size assumptions in their native code. And lastly, we have enabled 16K AOSP build testing on 16K AOSP build testing on RB3, RB5, SM8550 HDK devices and Android testing in Linaro. The testing so far is limited to Android mainline and AOSP main branch combinations, and around 200 reports have been sent out already. And that was a quick presentation. So if you have any questions, I'll try my best to answer that.
Yeah, so you mentioned on one of the slides that ABL problem with 16K pages. Is that something that's being addressed upstream in AOSP?
So the ABL is the Qualcomm's bootloader.
Ah, okay. So that's not the generic Android bootloader.
Right, it's not generic bootloader, no. So we have that flag set, and we are using that build on 3 of our devices, RB3 was 2017 device. So bootloader, there is no chance we get any kind of updates on that bootloader. But that's a very good point because I have not tested GBL. So the Android's upcoming GBL thing, and we are supporting GBL on all of our devices. Maybe I'll just go disable this flag and see how it works on GBL. But yeah, that was the bootloader problem, and nothing to we cannot fix that.
So I mean, so for the Android, so how many in the apps? I mean, the percentage is okay running with the 64 pages. Yeah.
So I don't know. So what we did, we downloaded the top rated apps from open app stores, right? And we realized that half of them works fine. So if I just take 10 applications as my sample size, which is very bad, but it's like 50% apps. But I'm assuming that more and more apps will be rebuilding and realigning with 16K page size as we speak. Okay. You're talking about the application support on 16K AOSP build, right? Yeah. So our sample size was very small. I don't know if we should be spending more time on checking this thing out. Sorry, so I'm saying that we have tested with only 10 or 12 applications.
Oh, okay.
Because we thought that, and the good thing for us is we got it covered all the 3 cases where the application was working fine because the binaries are 16K aligned. And then there are few applications that the ELF segments were not 16K aligned, but the applications were working fine. For example, the VLC. And then there are certain applications which did not load at all.
Okay.
So the 10 applications which I randomly downloaded, it covered all the combinations, I think.
Okay, thank you.
Thank you very much for coming.